the previous two triangles we've just discussed may seem to be a bit cumbersome because of the table that I showed you towards the end of the discussion or towards the end of the lesson, but actually it's the easiest way of doing it, as long as you're going to be able to remember all the special angles, particularly the 0, 90, 180, 270 and 360 angles in relation to your sine, cos and tan function. Now this one seems to be rather more comprehensive. This is our second method. Which actually uses the Cartesian plane. In this case, remember the Cartesian plane is something of this fashion. Then you've got a y-axis and you've got an x-axis, right? Now here the x-axis, we're going to have your circular drawing like that, that being your 0 degrees and your 360 degrees here, your 90 degrees there, your 180 degrees there, and your 270 degrees there. All right, now remember we're talking about angles 30 degrees. We're talking about angles, that's your 30 degree angle, and this one becomes your 45 degrees, and then got another one there, that will be your 60 degrees, 60 degree line, and then your 90 degree, then that's going to be your 180 and your 270. Now we're going to work it in coordinates, because remember I told you that your radius r, which is represented by this line, which keeps moving throughout the whole circle, and remember in the same circle the radius remains constant, that will be equals to 2, right? So that's the value 2 there. Now when we make coordinates using that 2, we're going to say the first coordinate here is, remember that coordinates are represented by two values, your x and your y, which is your abscissa and your ordinate. Ne? Now the abscissa and the ordinate, being the x and the y, are the same x and the y that we use when we are doing our trigonometric functions, using r for the hypotenuse, using x for the adjacent side, and using y for the opposite side. Okay, so that's basically what's happening there. Your r being the hypotenuse, your x being the adjacent side, and your y being your opposite side. Okay, now here we're having coordinates 0, pardon me for a second there, y is 0 here, y is 0 here, and my x here is going to be 2, because the distance from here to here is actually 2 units, you see. So that's my coordinates for this first point. Coordinates of the second point. Now I can talk about x being 2. It's going to change now. That's where you're going to get your x being the square root of 3. You see that? And your y being the coordinate against that line, which is 1. Okay, you see it, right? And then we go up again. That's at the 45 degrees. Remember, R remains constant, but the value for X and Y are changing, isn't it? Now for the 45 degrees, your Y remains, or my X at 45 degrees will be square root of 2 at 45 degrees, because this distance from here to here will be equal to the distance from there to there. That's going to be square root of 2 again for your Y. Okay, and then at 60 degrees, the coordinates of X and Y, that's where now your X is becoming 1 and your Y becoming the square root of 3. Square root of 3. Beautiful. Now at the top point, that's where now X is 0 and my Y is the distance from here to here. That's going to be 2 units. Okay, now as we move forward, now we've covered the 30, the 45 and the 60 degrees, right? As we move forward now, we're going to look at the angle 180. Remember, that was 0, 90. At 180, the coordinates are, remember, your units from the distance from here to here, it's going to be what? 2 units. So because it's on the Cartesian plane, it will carry a -2, and for my Y, I'll be having a 0. 0 for my Y. Good. And then here at 270, I'm having for my X, I have a 0, and for my Y, it's 2 units downwards. That's going to be -2 for my Y. Okay, and again back to the 360 point, where 0 and 360 actually share coordinates, because that's going to be X being 2 units and Y being 0 units. Now, if you're going to use this R, X and Y, where R is hypotenuse, X is adjacent and Y is opposite, you then have a situation where you can be able then to use your SOHCAHTOA acronym. Okay, then you know that your opposite is basically your Y, your hypotenuse is your R, your adjacent is your X, your hypotenuse is your R, your opposite is your Y, and your adjacent is your X values. So that's it. That's how you're going to distribute everything into your solutions, particularly when they said without using a calculator. So you must be mindful for these words as you do your trigonometric functions and solutions in trigonometry. Right, now that's about it. Now all these angles are accounted for on the Cartesian plane. You can get any angle you want, even if you want the cos of 180, 360, you can still use the same coordinates to be able to get those figures accurately. And that's it. Good luck.